Today I am going to discuss about the network layer of OSI model. You know that there are many layers in the OSI model. Other layers are applications layer, presentations layer, session layer, transport layer, physical layer and data link layer. Physical layer, data link layer and network layer belong to lower layer protocols, and transport layer onwards, transport layer, presentations layer, session layer and applications layer, they belong to upper layer protocols. And today we will discuss about various issues related to network layer. Now the main issues which we are going to take up are the two basic broad issues which we will be covering here. Is first is type of services to be provided by the network layer to the transport layer, and the second one is the responsibilities and functions of network layer. Now basically we have been talking about, we have taken 2-3 sessions on the network topic, and you know that each lower layer in the OSI model supports certain services to the higher layer. Like for example, data link layer provides certain services to the network layer provides certain services to the transport layer, and so on. And each lower layer provides certain services at certain point, what we call them service access point. For example, in your house also you see that electricity supply department provides you electricity services at certain point. You have a socket and so on. Same way, on same model, the network layer is designed that lower layer provides certain services to the higher layer at certain point, what we call them service access points. So the two issues which we are talking about, what type of services a network layer provides to the transport layer, and what is the basic functionality of a network layer. Now let's examine now. Now what we are talking about is that when we have the service, when we talk about the services, now each service, now just in this case, the services, whatever services a network layer provides to the transport layer, they should be independent of the subnet topology. Whatever subnet topology we have, but the services provided by the network layer to the transport layer, it should be independent. Does not matter what topology or what technology you have another side, but the services are designed independent of the what we will call them of the subnet. The second point is that the transport layer should be shielded from the number, type and topology of the subnet present. So the services, the important message which I want to convey is that services are not based on what type of technology we have. We have X.25, we might be having ATM, we might have some other type of topology or technology, but services are independent. So when we say OSI model is not designed around any technology. They basically define certain rules and regulations, and there are various other standards which basically design around these specifications. Now the point is which we are talking about is that which I have already discussed is the network address made available to the transport layer should use a uniform numbering plan even across LANs and WANs. What exactly we are talking about is that if the packet moves from one LAN to the another WAN or another LAN, they must have the unique numbering system. So we will talking about all these things when we talk about what type of services they provide now. So now coming back to the topic which we have started now. So I broadly talked about two basic issues we are going to discuss. One is what type of services we are going to take up, and the second is the responsibility now. So broadly speaking, a network layer provides two types of services to the transport layer. And what are these services? Just here is one is what we call them connection oriented service, and the second one is called connection less service. Now connection oriented, you all have been talking to somebody on telephone. Now telephone is basically, when you talk to somebody on telephone, is a basically connection oriented setup. Now what you do first, before talking to somebody, first you establish a connections, then you know that who is talking to another side, and then you start talking to them. And the second one is what we call them connectionless service. Connectionless, so basically in connection oriented you have to have some connection setup, whereas in connectionless that you don't need to have any connections at all. For example, when you send telegrams or send telephone, send various other postal informations, you don't need to have a prior setup between the place where you are sending the informations now. So each letter which you send must have source and destination's address now. Now what we are talking about is that if same day if you send 5 letters, all the 5 letters to the same person, then all these 5 letters will must have the source address and destination address, and all it might happen that all the 5 letters will be reaching not at the same time but at the different, and not one after another also. So what we are talking about is when we have a connection oriented, when we send a packet using connection oriented, all the packets will be dispatched in the sequence. First packet will reach first, second packet will reach after the first, and so on. But when I send 5 packets using connectionless services, not necessarily that they will be following the same route. It means that they all not be reaching one after another. They might be following since they will be following different routes, so we can't predict which packet will reach first. Although you have sent packet number 1 first, but using the connectionless, you can't predict that packet 1 will reach earlier than all the remaining packets. The reason is they might be following the difficult route, they might be following the longest route, so you can't predict. But when we have a connection oriented, the route is the same, a route is set prior to sending the packets, and one can easily so the packet will be reaching at the destination in the same sequence in the way you have dispatched the packets. Now, so basically let me summarize now what we have already discussed in context of the connectionless service now. So when we say connectionless service, connection oriented, we have understood that everything will be in the order. Connection has to be set up prior to sending the packets now. But when we have a connectionless service, then what is important is no packet ordering. 5 packets to send one after another, but again they will not be reaching in the same. No flow control. Flow control is important problem. When you at a data link layer also we have discussed the flow control problem. At the network layer we have to discuss it, and again at the data transport layer also we have to discuss now. Let me first list all the important services comes as a part of connectionless. No connection setup required, already discussed. Error control by host. Now let me briefly talk about now the flow control problem. Now flow control problem we know from the data link layer. Now we have a sliding window protocol mechanism which handles the flow control mechanism. What exactly flow control mechanism is? Flow control mechanism is basically related to memory management. Now suppose that you have a fast sender and a slow receiver, then what will happen? Most of the informations will not be received by the receiver. So it means that the receiver should accept as many as data which it can receive. It means sender and receiver must be aware of that the memory capacity about both of them. So it must be total agreement between the two of them. So what we are talking about, so we have various mechanisms are supported for the flow control. At a data link layer we have a sliding window protocol, and there are 2 approaches to handling sliding window protocol. One is what we call them go back in, and second one is called selective repeat. So again flow control problem is not important at the when we say what we call them, this is a basically flow control problem now, what we have already discussed here. But when we say connectionless service, the flow control is not a big issue now, but you have to understand what is really a flow control problem otherwise. But about the flow control, we'll talk about much more when we discuss the transport layer problem. But in connectionless service, yes, we don't talk about the flow control problem. Now, so basically, now we have to understand the important thing about is that how the subnet is organized. In data link layer, we don't discuss with these basic issues now, because we are talking about that you are basically we basically discuss with one cable segment and so on. So you are basically talking about point to point type of connections in data link layer. But here the network layer is also called lower layer end to end protocol. So now the point is that your packet will be routed through number of routers. We'll talk about routers little bit later on. A router is a device just like a bridge which we have discussed at a data link layer. And you know that the bridge is a hardware device which connects multiple LANs. In your organization, you can have a number of LANs, and it is job of a bridge to connect one LAN to another LAN. So you might be having CSMA/CD LAN. You might be having Ethernet LAN, somebody might be having 802.3 LAN, and if you are passing the data from one LAN to another LAN, bridge is required. Bridge is not just like a jumper or simply a connector. It is an intelligent device. It has to resolve many things, and all these topics we have discussed it earlier. So we have decided how the subnet has to be designed. So when we say subnet, what we mean is that it is a set of routers. Set of routers, it means that when I am sending the packet from India to some other country, it might be passing through number of the routers. Now, how these routers will be designed, this is what we are calling them the subnet now. So the two approaches for designing this subnet. One is what we'll call them the virtual circuit. Just see here now, right? The virtual circuit is the subnet designed based on virtual circuit is very similar to how we design a net, how we design a system using connection oriented. Now the datagram, and we'll discuss all these points. Datagram is again, so I can design my subnet using the virtual circuit. I can design my this one using the datagram. Now when we say the virtual circuit based subnet, it means that not necessarily that all the routes will be physically connected with each one. It's not like that. Each subnet, each route of the subnet will be given certain virtual circuit number. When we explain how does a router work, you might be getting this point, what exactly mean virtual circuits now. So each route, each router must be having certain table, and with each route certain virtual circuit number is assigned. So when we say virtual circuit, it's not a physical circuit, but it works just like a connection oriented service. Means if I have to send 5 packets using virtual circuit subnet, all the 5 packets will be using the same virtual circuit number. But when I am sending 5 packets using datagram, then all the 5 packets might be following the different routes. So you don't have a fixed virtual circuit number. So here is the difference between the two is what is the difference between connection oriented and connections less protocol. Now let's let's define once again what we have discussed in with proper let me give you proper explanation of what is the virtual circuit. Now just in this case, in the virtual circuit, the packet follow the same route. Each router must remember where to forward packets for each of the currently open virtual circuits. So there is a router which decides that how to route this packet, how to route this packet. They must have a table, and for certain route virtual circuit number is decided. So the router will assign certain virtual circuit number to this packet, and this packet will follow that route which virtual circuit number matches with it. And the second end, what router does, how router is able to assign this one, each router must maintain a table with one entry per option virtual circuit passing through it. So each router is having certain table, what we sometimes call hash table. In hash table contains is 2 column number, might be one might be related to the packet number or the node number from data is being transmitted or to whom data is being transmitted, and the second column number will contain the virtual circuit number and so on. When we explain you how does a router work, we will understand what we are talking about here. So this is called virtual circuit, not physically assigned, but they will all follow the same route having same virtual circuit number. Now, so we are all the time we are talking about the router. Let's try to understand what is a router now. You know that bridge is at a data link layer. Each layer we have certain hardware device. At a data link layer we have a bridge. So we keep on asking, give the names of the devices used at each layer. So now bridge is one device used at the data link layer. If somebody asks you what type of hardware device we used at network layer, the answer to this question is that it is the router now. So let's see once again what is a router now, how can be defined. Now routers operate in the physical data link and network layer of the OSI model. The router not only work at the network layer itself, router also works at the physical layer now. Now it has access to network layer address and contains software. So it is not only a hardware device but also contains some software It is an intelligent device. It is programmed accordingly that enables them to determine which of the several possible paths between those addresses is the best for particular transmission. So it has to decide, it has to find out the best optimal route available between the two. It's not simply it has to transmit the data. In data link layer, we don't discuss with all these issues now, but the important functionality of the network layer, which I will discuss little bit later on, to find out the optimal route. So it is the router which will decide what is the optimal route between the source and destination. There might be many routes are available then, but it is this job of the router that which is the optimal route, because if they have followed the longest route, one has to pay price for it. So all these issues has to be examined at the network layer. In data link layer, no, not at all. We don't discuss with these issues, because we are talking about point-to-point communication only between the source, between two end machine which is connected by this simple cable now. But here we are talking about two machines. They might be located at two different places, two different countries, and the data will be passing through numbers of routers and gateway and so on. So they have to find out the optimal route between the two. So now let's see in this case, just this diagram simply explains you how just you follow the color, how things are movement here. See right now what I'm trying to show you, just see this color you try to follow. Now first thing here is, if you follow this one, it says that how to transmit the data from this one to this one. Now let's see this one. So I want to transfer data from this one to this one. Now it looks for, this router has a table, it looks for that on which segment this node is available, and then finally the basically data transmits there. So this is a router. This diagram shows you how does a router works. Now what I have explained you already, that each router maintains one small table, and this table contains the subnet and on which segment data has to be passed through it. So this shows that where from which node data has to be transmitted, and now on what segment, what is the optimal route available, that will be noted here. Because we have only 4 or 5 segments, so we have simply shown you that which segment they have to follow it. But there might be many segments, and one has to find out the optimal number of lines between the two. So this way your router works. Here is one set of node, here is another set of node. This is located on one segment, this is available on another segment, this is available on the third segment, and data is being transmitted between all these 3 segments, and it is the router who has to decide how to follow this route. Now this might be located in one country, this might be located in second country, there might be number of routes available between this one and this one, or this one and this one, and it is the router which has to find what is the optimal route. So you have to understand how does the router works with this diagram. So they have a table now. Actually from data structure point of view, you have done a data structure course. In data structure we have taught you what is the hash table. So basically each router maintains the hash table, and all the entry points are stored into these hash tables. So if your routes keeps on changing, you have to restore those values in the hash table of particular router. So one passes through number of routers. Here I have shown you only one router, but there might be number of routers available between the two nodes. So again it will be much more complicated exercise what I have shown you in this diagram. Now so basically the job of the router is that it relay packets among multiple interconnected networks. I have shown you only, when we say interconnected networks, there might be number of, for example, internet. Internet is an example of interconnected networks. We are not talking about one machine to another machine, but there are number of machines now. So what the router does? A router relay packets among multiple interconnected networks. They route packets from one network to any number of potential destinations networks. We are not talking about a router is used for connecting two machines. What we are talking about, a router is used for connecting two sub-networks, two networks. One might be another LAN, it might be something wide area network, and so on. So internet is basically example of internetworking. So again the data has to be passed, again the router has to be used. Now let's try to understand now. We basically what we are talking about is there are two different approaches for designing the subnet, and subnet is basically a set of routers. So if you are sending the packet between the two machines, it passes through number of subnets. And what we already discussed is there are two approaches for designing the subnet. One is the virtual circuit approach and second is called datagram approach. Let's try to understand the difference between the two. Now let's see this diagram, this table just now in this case. So let's say I will be examining them. I will take up many number of issues and I will try to examine that how the datagram subnet is different from the virtual circuit subnet. So just see this in table now. Let's try to understand. I have a now I have to route the packet. So let's say whether do you have to set up any circuit. So the first issue is whether circuit setup is required or not. Like in telephone, yes, you have to have some circuit is established, then only you are talking to somebody. So now, if we examine the difference between the two on this issue, you will see that in datagram subnet, not needed, because each packet will be following the different routes. In VC subnet, you require a circuit establishment, then only packet will be transferred. Now it means that if you have a circuit established and if you want to send 5 packets, all will be following the same route, but in the datagram subnet all will be following the different routes. Let's examine the second point now, what we call them addressing now. So if you see the addressing, each packet contains the full source and destination address. Now so just like when you send a letter, if I have to send 5 letters to my friends, each letter will have contain source and destination address. Now same way that if I am sending packet through datagram subnet, each packet will contain source and destination address. But what will happen in the VC subnet? In VC subnet, no. Once the circuit has been established between the source and destinations, then you don't need to have any circuit setup at all. You don't need to have a source and destination address for each packet. Automatically, they will be following the same route. Let's examine some other issue now, differentiate between these for differentiations between the datagram subnet and VC subnet. Now the third point is the routing now, how the packet will be routed now. Now already we have explained to you all these things, but let's try to understand now. The third point is what we call them routing now. Now routing is that in datagram subnet, each packet will be routed independently. Right? That is why each packet contains source address and destination's address. But what will happen now in the VC subnet? In the VC subnet, once the route is chosen, once you have route has been set up, then all packet will follow the same route. So this is very important thing you have to understand, how the subnet is designed and how other issues are basically taken up there. Let's try to what will happen now. Suppose the router has failed. Router has failed, then what will be its impact on the VC subnet and what will be its impact on the datagram subnet? Now just in this case, what is happening is that if the router has failed, and I have shown you router there in the earlier slides now, if router will fail, then what will happen in the datagram subnet? They will not follow, because all our packets are following the different routes, so it will not have a major impact on it. If one route is failed, it will follow the another route. But of course, what will happen now? If you have established a virtual circuit, right? And in that circuit, in that route, if the router has failed, then all basically the packet transmissions will be terminated. So it will have some impact there. Now let's examine the last issue now. If you try to compare between the datagram subnet and VC subnet now, what we call them congestions control. Now congestion control is the important issue. We will discuss what is the congestions now. Now congestion means that lots of packets have already reached into the subnet. Now if there is a congestions, then what will happen is very difficult to handle this in the datagram subnet. But here is one can easily handle the subnet. You can easily handle this type of situations in virtual circuit if you provide more memory. These congestions happens always because the memory is not sufficient enough for incoming packets now. But since one route is decided, you know that flow of the packets in that route, you can handle the congestion very easily by providing more memory to the routers at that route. So here is what we are talking about is that we have talked about the difference between, so far we have discussed the what are different approaches for designing the subnet. We gave you virtual circuit subnet, datagram subnet, what is the difference between the two, how does the router works, right? Now let's try to, so all the time we are talking about the, that the important functionality of a network layer is to find out the optimal route between the two, between the source and the destinations now, or between the client and the server now. So let's try to understand what do we understand by what is the routing algorithm. Now let's hear the small definitions for you. The routing algorithm is that part of the network layer software responsible for deciding which output line an incoming packets should be transmitted on. So what exactly we are talking about? There might be many output lines for data transmissions. It is the job of the network layer algorithm to find out what is the optimal route. So we call them routing algorithms now. Now they are basically, what we are talking about is now how the routing is basically, we are talking about how the routing is decided into, let's revise in the datagram subnet. Now new route for every incoming packet. Now if you have a datagram subnet, then every time a packet is coming, the packet has to be given a new route. But in the virtual circuit subnet, no, for all the packets between the source and that destinations, if virtual circuit has been established, then route has to be fixed and they all have to follow the same route. Now, so basically there are two types of routing algorithms. Now what are those one? One is called non-adaptive algorithms. The large number of algorithms are available for finding out the optimal optimal routing algorithm. One is called non-adaptive algorithm and second one is called adaptive algorithm. The by meaning is understood, non-adaptive means that what we are talking about is, sometimes also we say that the two types of routing algorithms are available. One is called static algorithms and second is called dynamic algorithms now. What exactly we say non-adaptive algorithm? Just say here is the definition for you. The routing decision, I'm talking about what type of algorithms belong to non-adaptive. The routing decision is not based on measurement or estimates of the current traffic and topology, also called static routing. So now what exactly it means now? Suppose that the route you have decided between two machines, this is the route number one has to follow now. Now suppose that what happens is there is lots of traffic on that route, right? So then since the route has been already decided in advance, even if there is a congestion, if there is some router failure on the way, the route cannot be changed. That is why we call them static algorithms now. It is much easier to design this type of algorithm. Even otherwise, if you have done a data structure course, in data structure also we are talking about this type of algorithm, finding out shortest path algorithm. So again, is very similar to routing algorithms now. Distra's algorithm you must have studied in your data structure course, and that is again same type of algorithm we use here also to find out the optimal route now. So it means that when we say non-adaptive, means the route is fixed, does not matter what happens on the route, congestions, there is congestions there is a memory failure or there is some other failure, router's failure, the route is fixed now. Now let's see what is dynamic algorithm then. Now dynamic algorithm, what we call them adaptive algorithm, and here is the definition. The routing decision is based on changes in the topology and usually the traffic as well. So if traffic pattern is changing, if there is high congestions on that line, high traffic is going on a particular line, then if router is designed for adaptive type of algorithm, they have to find out the best route on the fly. So they keep on changing the route according to the topology changes or some congestions occurrences or some router failure and so on. And a very important algorithm which we are not going to discuss at this level is called Bellman-Ford's algorithm. So you simply have to be aware of that Bellman-Ford's algorithm is called dynamic routing algorithm, whereas the Distra's algorithm is what we call them static algorithms. Now, so what happened? What is the basic reason for the congestions now? Now the many regions now, I will just list few of them. Here is the sudden arrival of the packets for a particular output lines. If a number of packets on the same output lines, it will lead to congestions. The slow processor, suppose that the data is coming from very fast processor, but the receiver side it is very slow processor, so the packet will be not be processed easily by the destinations machine. All packet will be circulating in the network, so there will be congestions. Now congestions tends to feed upon itself. If you have a more congestion, it will lead to further congestion and so on. So congestion is the reason for the further congestions. This is what we are going to talk about. Now what will happen is, let's see the another reasons now. So what will happen now is, why not we have resolved this congestions problem so far? The policy has been designed, take example of the TCP/IP protocol itself. The TCP/IP protocol has been designed in such a way just for the reliability purpose that it can lead to congestion. What happens in TCP/IP, you must be aware of, we have already discussed this topic number of times, that whenever a sender sends a packet, they start their timer. Let's say for example the distance between two machines are 5 milliseconds, so the timer will be out after 5 milliseconds. If there is a acceptance, there is a acknowledgement of the packet from the receiver, then there is no problem. But if the acknowledgement didn't reach within the 5 milliseconds, then the sender will think that packet has lost. Although packet has reached well, but acknowledgement was not reached because of the slow processor or whatever be the reason. Then in that case, the sender, the TCP/IP client might or server might be sending same packet. Now already that packet is there, the second packet is already reached. So this way the number of packets will be sent and it will lead to congestion. What we are talking about, that we have a different layers, and the policy of the each layer also leads to congestions now. So here is number of the regions for the congestions now. One region is VC versus datagram inside the subnet. Now how you have made your subnet, that is another region for this one. The packet queuing and the serving policy, what will happen? Now you have the same route and there is a condition, the packet will be not be delivered, so number of packets will be arriving on that, and this again it will lead to congestions now. The packet queuing and service policy, how fast, what is the method of servicing those packets already received now. If the servicing policy is very fast or some appropriate type of service policy you have taken up, the congestion will not take place, otherwise again it will take place. So we have a packet discard policy, how long quickly you are discarding those packets. The routing algorithms now, just see, so we have talking about number of regions now. And the last one, what we call them packet lifetime managements. Now for example, the routing algorithm, what is the best, whether you have a optimal algorithm for transferring the packet between the two machines, this will also decide that whether congestion will take place or congestion is not going to take place, and so on. So there are number of regions for the congestions now. Now let's say basically, so what will happen now is, let me define now properly what is the congestions. But already you have understood that if number of packets are very large which can be delivered by the network, then it leads to congestion. Let's see, have a proper definitions for the congestions now. When too many packets are present in a part of the subnet, the performance degrades, and this situation is called congestions now. So the congestions refer to situations where the performance of the network is degraded because lots of packets have arrived in the network, which the network is not able to handle them. Now a small graph is there, you can understand now. This is the graph which is showing you what happens is that there is a certain, if packet, the sent, whatever packet has been sent, if it is the desirable level of, now if you have, let's say I have 500 packets a network can deliver. If you have sent 5 number of packets, all the packets will be delivered. But what will happen is, if the packet size, if number of packets has exceeded, let's say 500, then it will lead to this type of situations. So all the packets will be discarded, and this type of situation is called congestions type of situations now. Means that if network handles only 500 packets, below 500 or till 500 everything is all right, but moment you have exceeded the 500, the number is not indicated, all the packet will be discarded, they will not be delivered now. So the reason is that the policy has been designed, so there is always trade-off now, what exactly you are looking for the reliability purpose, for the what we call them quality of services type of things. Then we talk about certain policy have been designed, but they also lead to congestions. So now the point is what we'll call them internet working. This is another important features of the network. Now what is the internet networking? It's one word. The goal is to build a unified interconnections of networks that support a universal communication service. So what we are talking about, let's say protocol called TCP/IP. TCP/IP, right now what we are talking about, a router basically. Router what does? Router is a device which basically supports internet working. We are not talking about connecting two machines. What we are talking about, connecting two networks. So the internet is example of internet working. So TCP/IP protocol is designed for the internet working. A packet can move from one network to another network. This network could be a LAN, it could be wide area network, it could be number of wide area networks, number of LANs and so on. Now basically, so right now the TCP/IP protocol is standard protocol. So in a TCP/IP internet, the computers called routers provide all interconnections among physical networks. Routers route packets based on destinations networks, not on the destination's host. So this is called internet working. So another important functionality of a network layer is to support the what we'll call them internet work. Now again, once again, when we say the TCP/IP internetwork protocol treat all the networks equally. So when we say internetwork, all the packets belonging to different networks are treated equally. A LAN like an Ethernet, a wide area network like NSFNet backbone, or a point-to-point to link between two machines, each count as one network. So when we say internetwork is a large set of networks, and we are not concerned about what type of network it is, they all will be treated by a protocol just like a one single network. Now let's talk about this is what I wanted to discuss about the network layer. So we discussed number of issues and important issues that network handles congestions. So one of the functionality of network layer is how to handle the congestions. The second one what we discuss is how we design the subnet. We also explained you how does a router works and what type of service is provided by network layer to the transport layer, and all the services provided by the lower layer to the higher layer is based on certain point, what we'll call them service access points. Let's talk about now, today I'm going to talk about the transport layer now. Transport layer is another fourth layer in the OSI model. So we'll talk about the functionalities, the features of network layer. And the standard protocol is for the transport layer. There are two standard protocols. One is what we'll call them TCP, and second is called this one. Let's see what are the basic features. What is the transport layer now? The transport layer is basically the heart of your computer network. You are a Java programmer, you know that in Java programming, multi-threading is the heart of it. In C programming, a pointer is the basically heart. Or we can say that in Java, the internet is basically heart. Whole Java programming is designed around the internet. So internet is the split of Java. Same way, the whole computer network design, the transport layer is the heart. So transport layer design is a much more challenging task now. So now what happens, what transport layer does, just see here is, the one important thing is that it acts as an interface between upper layer protocols and services provided by the lower layers. Already we have discussed now that from the transport layer onwards to applications layer, they come as a higher layer protocols, and from physical layer to the network layer we call them as a lower layer protocols. So it is the transport layer which provides an interface between the services provided by the lower layers and the higher layer protocols. Now what are the responsibility now? The responsibilities are many. Now what is first is end-to-end delivery of entire. We are talking about end-to-end. Although we don't talk about end-to-end at the data link layer and so on. Here we talk about end-to-end delivery of the entire message. The connection establishment and termination, establish the connections, the segmentations and reassembly, flow control and multiplexing. Now the most important thing is like what we are talking about, reliable way. So what exactly a transport layer does? We have listed number of functionalities now. What we are talking about at here is that transport layer provides the reliability now. If your network layer is not working very well, if network layer does not support the good services, it is the job of the transport layer to provide the better services now. The other issues were again flow control problem, again very important flow control problem, which we are going to discuss little bit later on if we get the time. The another important thing which you have something new is what we call them the flow, what we call them segmentations now. Now what happens is that sometimes you have sent, let's say, 1024 byte of packet you are sending, but a router on the way are not basically, or some other devices will not be able to accommodate 1024 bytes of packet. So what they do, they might be able to fragment this packet into number of segments, but finally they all have to be reassembled so that the logical meaning of the program should not get lost. What happens, suppose I have broken my packet into 5 segments, segment 1, segment 2 and segment 5. Segment 5 might be reaching earlier, segment 4 might be reaching later on because of the number different routes they might have followed, but they all have to be reassembled such a way that the meaning, semantics of the packet should be intact. Against all these issues are discussed at the transport layer. Now let me see now what we talk about. The another important task, responsibility of the transport layer is that they provide certain services. Just like a network layer provides certain services, transport layer also provides certain services. We are also going to talk about quality of service. That is, we are talking about reliability factor. Reliability is the most important considerations in designing the transport layer. Transport layer designer always assumes that all these lower sub layers are not very reliable type, so they have to provide this factor on top of it. And we'll talk about certain what we call them transport service primitives. If you are going to write a if you are involved with TCP/IP programming, you have to be concerned about transport service primitives and so on. So let's try to talk about now what type of services a transport layer provides to the network layer. Again, there are two types of services provides, just like a network layer. One is connection oriented transport service. Just like connection oriented, we have virtual circuits and other things. Connection list transfer service, transport service. So these two are again in same line at the network layer, which we are not going to discuss separately. Now the question is, the students keep on asking this type of question: if the transport layer service is similar to the network service, why are there two distinct layers? Why is one layer not adequate? Now the point is like this. Now what we have been talking about is that if you remember data link layer also, we are talking about all these issues which we have taken up the transport layer and even at the network layer. Now the question is, then if all these issues are discussed at the lower layers, why you require another higher layer? The answer to this question is that in other layers we are simply talking about the two neighbor machines, but here in the transport layer we are talking about two end machines. We are talking about end-to-end machines. In the one client and server type of situations we are talking about. Client might be in one country, the server might be another country, and in between there is a subnet. So this is a problem. We have different type of environment at the transport layer. That is why all the issues have to be re-examined. And if other layers are not very reliable, then it's a job of the responsibility of the transport layer to provide the better services now. Now, so what are the parameters now? These parameters are very important when you want to design a transport layer. One is called connection establishment delay, connection establishment failure probability, throughput. So when you try to examine various protocols and what is the standard protocols in the transport layer, it is called TCP/IP. To understand transport layer, you have to understand TCP/IP protocol and UDP protocol. Transmit delay, the residual error ratio, protections and priority. So all your transport layer protocol must provide all these quality of service parameters now, right? So if they all provide, it means that that transport layer, so TCP provides all these parameters now. Let's try to examine a few of them. Now what we are talking about is, first is, let's talk about connection establishment delay. What is this one? The amount of time elapsing between transport connections being requested and confirmations being received by user of the transport service. So now the time, suppose that I requested for certain service, I want to send a packet, I want to do some FTP, I requested to the transport service that this at 5:30. If I am getting at 5:35, if I got the connections at 5:35, then the time elapsed between I requested and the time I got is basically 5 milliseconds. So this is called connection establishment delay. We are talking about that it should be much more lesser than that. If 5 milliseconds is too much time, one has to wait for it. So if the time is very less between this request and the delivery, we say that connection establishment delay is very less, and it should be. The second one is what we call them, the second parameter is the connection establishment and what we call the future probability. So what is happening here is the chance of a connection not being established within the maximum establishment delay time, for example due to network congestions or lack of memory space or whatever be. So basically what we are talking about is the time delay is given, okay, within this time it has to be established. Even within this time, due to some other reasons are not, connection is not given, so we say that this is the connection establishment parameter and so on. The third one is what we call throughput. That is very important parameter now. By throughput means number of bytes of user data transferred per second measured over the some interval. How many bytes have been transferred? You remember, if you remember that graph where I was talking about the packet, the transferred and packet sent. So suppose that I have a, let's say for example, take example of the Aloha protocol now. Just to little bit deviate from the topic now. Aloha protocol, we say that the throughput is 18%. What exactly it means? That Aloha protocol, if you have sent 100 packets into the Aloha network or Aloha protocol, only 18 packets will be transmitted to it. So throughput of Aloha is just 18 now. Take example of throughput of slotted Aloha is 37%. It means that 100 packet you send, only this 37. But if you learn the higher protocols, let's say token ring and token bus, the throughput is much more higher. So TCP, the transport layer protocol, has to be designed such a way that the throughput has to be maximum. The transmit delay now. The transmit delay measures the time between a message being sent by the transport user or the message delivered on the source machine and is being received by the transport user on the destination machine, right? So basically what time it is being received at the destination. I send my packet at 5:30 and then is basically it is received at 10, let's say 5:35. So the transmit delay should be is 5 milliseconds. So it should be again minimum. So all these parameters have to be minimum, except the throughput what we are talking about, all has to be as less as possible now. The residual error ratio, again another important now. The number of lost or garbled messages are a fraction of the total sent. How many packets you sent, how many packets were discarded due to, or how many packets got lost. I have got 20 packets and I got acknowledgement of only 5 packets, means 15 are basically garbled now. So what we are talking about is basically 15 by 20, and that is called residual error ratio. Now the priority now. Again the priority is very important thing. Now what is the priority? Let's see here. This is used to indicate that some of the connections are more important than other ones. And in the event of connections, to make sure that the high priority connections get serviced before the low priority. If you work with Unix operating system or any other operating system, the administrator is given the high priority. Same way that somebody might have established certain connections and that connection has to be given high priority. So the protocol must support that certain type of connection has to be given the high priority with whatever reason may be, and the certain type of connection should be given the low priority. So it means if the high priority packet should be delivered first than the low priority packet, even if high priority packets reach much more later than, arrived in the network much more later than the low priority. So the protocol must be able to support all these basic issues. Now, so basically now let's talk about, so we discussed what are the parameters now, quality of service parameters, and all the protocol must be able to support. Now let's see the primitives now. These primitives are very important for you when you are going to do programming, when you want to become network professional. Means if you want to do some TCP IP programming, for one example, of course you can do many things in the network programming, but one one way to enter into the networking side, that one can enter as a TCP/IP program. In TCP/IP programming means one can write a program using one client, many server, one server, many clients, and so on. So here is, you have to program. So all these primitives which I have brought is basically used in the TCP/IP protocol. Now what these primitives are there? You have to program these primitives, right? So let's say, for example, let's talk about the first one. Let's say the listen. We have, what are the primitives are? We have a listen is one primitive, connect is another primitive, send, receive, and disconnect. Let me talk about briefly what these primitives are. Now what happens is, when we write a client server type of application, there is a client application software and there is a server application software. Now server is basically keeps on listening to the client on particular port number. For example, you might have surfed the net. Now you might have be looking for certain information through Yahoo server now. Now Yahoo on its own does not do anything. Yahoo keeps on listening to a client on certain port number, right? Depends upon what, right? For example, all the standard protocols are basically using certain port. Let's say HTTP, always you surf the internet, they always use port number 80. Then we have FTP, they always use port number 21 perhaps. So now all are listening to a port number. So the listen primitive is used by the server, right? Is not used by the client. So client server is always keeps on listening to the client at particular port number. And then connect, then if client makes a connect, so connect is done by the second one is used by the first is listen by the server. The connect is that it is the client who has to make connections with the particular server. So the connect primitives will be used by the client, and then once there is a connection between the server and the client, then simply client has to make a request using send. Then server will be receiving this request and sending the reply using the send, and so on. And finally, if the client does not want to have any further connection, client has to disconnect all this information. So now the point is like this. If you want to write a client server application using TCP/IP, you have to basically use these primitives. Listen for the server side, connect for the client side. Then once there is a connections between, there will be transmissions of the packet between client and server using send and receive. And then finally you have to disconnect. So disconnect will be used by the server side. So these are the important things you have to understand. Of course, you have to learn the TCP/IP programming, and TCP/IP programming not very difficult task. It's very similar to what we do in C programming. In TCP/IP, just for your information, comes as a library in the Unix operating system. You don't need to download any other package. When you are working with Unix, you are simply TCP/IP. You can use the services of TCP/IP using one of the library feature. Now let's see the gateway now. Just see this diagram now shows you now. So now this diagram says that again what we are talking about is that at each layer we have a certain device. At the bridge, at the data link layer we have a bridge. At the network layer we have what we call them router, and at the gateway is used at the transport layers. Again gateway is used to transmit the data, and as you go higher, more intelligence is put into all these devices. Now let's see what this device is. It's basically showing you the signal between the two subnets or two networks using the gateway. Now what it does is a computer that performs protocol conversions. One network might be using the X.25, another might be using ATM, and so on. So it's the job of the gateway to convert a protocol from one LAN to another LAN. So this is the job. So basically transmits the data from one net to another net by using the conversion of the protocol. Now let me see the two other important concepts, what we call the multiplexing. Now multiplexing is basically what is that? At this layer has two options, what we call them upward multiplexing. Many transport layers use the same network connections. And then we have a downward multiplexing. One transport layer uses many network connections. Now what will happen now, just in this case, the multiplexing we have used at the physical layer. In physical layer, you remember that we discussed two approaches for multiplexing. One is what we call them FDM, and second was called TDM. You have a cable TV. In cable TV, you use basically FDM and TDM. At a data link layer, we discuss different type of multiplexing technique, much more dynamic techniques, what we call them CSMA, token passing and token ring. Here also we have same style we are talking about is that whether one transport connection requires more channels or a single transport can use number of other things. So what we are talking about is, just see once again this slide now, many transport layers use one of the same network connections, and the second what we call them downward multiplexing, one transport layers use many network connections. So all are basically is called multiplexing. Now the another is important is called flow control problem. Now flow control at this layer is performed end to end rather than a single link at a data link layer. We also do flow control, and sliding window protocol is the basic protocol mechanism at the data link layer, but here we are talking about end to end, so flow control is a little bit different. What transport layer flow control also uses is sliding window protocol. However, the window at the transport layer is to accommodate better buffer capacity now. So here is flow control is same line but little bit different, but because end-to-end protocol where you are talking about a single link in the data link layer. And this all we have. Let me summarize very quickly what we have discussed so far. The transport layer is the key to understanding layer protocol. If you want to understand the OSI model, if you want to understand even TCP/IP model, you have to understand the transport layer. Now what you have to understand in transport layer, you have to understand quality of service parameters. That's the most important thing. How the connection is established, how connection is terminated, how the flow control problem is resolved, how the multiplexing problem is solved, how gateway works, right? So all these issues. So if your network layer protocol is not reliable, it is job of the transport layer to provide reliable transmission between the source and destination. The next is what else we discussed, provides end-to-end reliable connection oriented service. Now the again also provides connection management and over unreliable networks. And the last, the data link and transport layer, that's very important, performs similar duties. The data link layer functions in a single network while the transport layer operates across the net. So now, so he's basically, let me very briefly summarize now, is that transport layer, you have to know the transport layer. Basically when you do the programming, when you do the client server programming, when you are designing the server and the client, you are basically designing the transport layer, you're basically using the transport layer primitives. So now with this I will be coming to an end, just to tell you that once again that you must study the TCP/IP very well, then only you will understand how does internet work, right? So internet and the TCP/IP somehow linked with each other, because TCP/IP is the heart of the internet layer, internet protocol. To understand the internet functioning, the TCP/IP has to be understood very well. Thank you very much.